So here we are today at the Latin American Association, and the Arduino Guild is of course participating here. We have Robert, and we're going to talk to Marty about what he's got set up. So Robert, you want to talk to us real quick about what you got here?
Yeah, what I got set up here is an ultrasound sensor and a thermal sensor hooked up to an old hard drive that gets hot. And I've got a PIR sensor that detects movement. And I'm going to show the kids how those sensors interact with the Arduino board.
Okay.
And then I'm going to show them the software that makes it work.
Okay.
So that's the main focus here.
All right. So do a quick demo.
Robots too, but
so do a quick demo for us, Robert.
Okay. Well, it's working right now. What it's doing is it's measuring the distance between you and the sensor here, and it's giving you feedback and telling you how far away you are.
Oh wow.
Okay. You see that? You're about 26 inches away. Very good. And if I put my hand in front of it and get really close, it'll come down to like you're 5 inches away. Back off, buddy. See that? When I put my hand in front of it, so it's measuring the distance. So I think the kids will get a kick out of that.
All right. So let's talk real quickly about the Arduino, and of course it does inputs, outputs, takes it through the processor, and then send the outputs. But tell us a little bit about the Arduino.
Well, the Arduino specializes in reading analog inputs from devices. And it's basically voltages that are, analog in nature. They're not like ones and twos or ones and zeros. And what it does is the board reads that analog voltage, and it's called raw data. You convert that raw data through software into something usable, like a temperature reading or a distance reading or whether there's motion, and then you write the software or make the software work in a way to activate something.
Okay.
So it activates a servo that does stuff.
Right.
Or let's say a fan. Okay. An example would be like hooking up a thermal resistor with the Arduino that detects if the temperature in let's say a stereo cabinet gets over 80 degrees, it'll kick on a fan and suck all the hot air out, or open a louver.
Right.
And then it'll close the louver when the temperature drops. So that's a typical example.
Right.
And of course, you can use it in robotics too.
Right. I remember the only thing we had when I was in school was we want to make a super duper speaker system. The only thing we had to work with was capacitors and inductors to iron out the different frequencies.
Oh yeah.
Because of how the resistivity changed as it flowed through through those particular components.
I used to make my own speaker boxes.
Yeah.
Using cardboard tubes, for the bass reflex.
Right.
I love doing that stuff.
Right. This is
It's
great.
very scientific though. I mean, there's formulas you can use.
Well, let's talk about your other item here, Robert, of the robot here.
Yeah. This is an easy project for a middle school student to do, where they can bring together the Arduino board, 2 servo motors, and a sensor, and make this thing walk using household items like a batter spoon, a ruler, and I used pen casings. You try to use stuff from your home.
Right.
This costs about $100 total if you take all the parts. And basically it runs off a 9-volt battery. And the software is already loaded via USB port. And you load the software and it'll start walking. In theory.
There we go.
And walk right off the table. And then the sensor, of course, works. It'll make it back up.
All right. Well, it tried to back up. Great.
Yeah, I gotta adjust that.
All right.
So it's not so severe of a backup. There it goes.
There we go.
It's almost like having a pet,
Yeah.
You see how it does
like
on the floor here.
Do we need to borrow that table down there with nothing on it?
Yeah. Oh, you know what? No, that's okay.
Right.
I wish my line sensing thing worked.
I want them so the kids can see it, so that we're not.
Well, that might not be a bad idea.
Right.
You know what I'm saying? So that the kids can see it up high, because once they all come around, we don't know how many.
Right. I agree.
So it's the same concept. It's bouncing a sound off an object. If we calculate the software, if it's less than 12 inches, the software says back up.
Right. Right.
And then it backs up. So you can see the application in robotics.
Right.
Very simple application.
And then one last thing, Bob, on this. I know what we got coming up, but tell the folks that what we're doing in January with the Memorial Middle School.
Oh yeah, we're going to work with Memorial Middle School in Conyers, Georgia. They're a Title I school. They've got some STEM money, or
Right.
at least they got some incentive to do STEM. And we're going to build that robot with 16 students.
Great, great.
They're going to raise the money to buy the parts.
Right.
We're going to help them do it, and I'm looking forward to it.
Right, that's going to be in January, I think, the 10th and the 17th
Yeah.
of 2015. So they need to raise almost $900, let's say $1,000, and they're going to do it with car washes, and then we're going to help them out as well.
Yep, and they're really excited about it.
Yeah. All right. Great job, Bob. Thank you now.